Welcome to the first lecture of our course. Why? We use statistics. We use statistics in order to make predictions or explain relationships. We want to make predictions from our data because we can see what features are effective or is the general process is profitable. We want to explain relationships because it can help on decisions. For example, if we know what is both together in our store, like biscuit and milk, we can put them together so we can increase our sales. In these days, most of the companies are data-driven, which means they are giving their decisions via the information from the past. Statistics is the key for any data-related process since we need to understand and need to make statistical tests in order to understand what our data tells us. What this course aims. This course aims to teach you the most important concepts with simple explanations and reducing the complexity. We will do a lot of examples with the formulas we learn, and I will try to teach every concept in the easiest way. What I recommend before starting, I strongly recommend taking notes in the old course process. Just watching will not let you learn the concepts and will lead to finish the course without learning anything. I also recommend trying so examples in the course by yourself so you can test what you learn and understand concepts clearly. I also recommend to contributing in a section quiz, which I will add in end of all sections so you can practice one more time all the concepts that is covered in that section. If I come to the lecture in this lecture, we are going to cover general concepts in statistics. Population versus sample population is a set of similar items or events of interest to a question or experiment. A statistical population can be a set of existing objects or a hypothetical and potentially infinite set of objects designed as a generalization from experience. Sample is an analytical subset of a larger population. Using samples allows researchers to conduct research in a timely manner with more manageable data. If the random sample is large enough, there is not much bias, but generating such a sample can be expensive and time-consuming. The size of the sample is always less than the total size of the population. Examples of sample and population. For the sample examples, we can say group of friends from an event, and for population, we can take everyone in that event for sample. Some players of a basketball team, and for population, everyone on that basketball team. Sampling types. Random sampling. Taking observations from the population randomly. Everyone has equal chance of being chosen. Convenient sampling. Observations that are easy to include in the sample are chosen. Systematic sampling. Observations taken in a systematic way. Qualitative versus quantitative data. Qualitative data is not numerical data. Quantitative data is the numerical data.